Hi, in this video we're going to use a speed time graph in order to solve a mechanics lift problem. So I'm not going to read the whole question out, I'm just going to do it bit by bit. It says, a lift in a tower block takes 1 minute to descend 324 metres from an observation deck. It starts from rest, accelerates uniformly for 12 seconds to a constant speed, which it maintains for some time, and then decelerates uniformly to stop at the ground floor. The mass of the lift is 6 tons, and on the day in question, it is carrying 8 passengers whose average mass is 75 kilograms. It says, sketch a speed time graph of the lift. Okay, so if we draw our axis, we've got time along the horizontal axis, speed or velocity in the vertical axis. So it accelerates for the first 12 seconds uniformly. So that will be a straight line, travels at constant speed, and then decelerates uniformly and then does that in 60 seconds, i.e. 1 minute. Okay, so what's going to be important is this point here, which is I'm going to call capital T, and the length of this time here, i.e. t minus 12, we're going to have to find that as well. Okay, drawing diagrams, which is very, very important in mechanics. So there's my lift. So I've got the tension going upwards. I've got the mass times gravity force going downwards. And then I've got the passengers. I'm just going to represent that by 1. So there's 8 times 75. So their total mass is 600 600 kilograms, and therefore their force will be 600 G. Okay, them standing on the lift will make a reaction upwards, and therefore that reaction will also be downwards. Now, making equations of motion, which is another important thing, so set this out very carefully. So, just one other thing, we've got the acceleration acting downwards, and we're going to take downwards as positive in this question. So in the lift, we've got going downwards 6,000 G plus R newtons, and then against it we've got the tension, and that's going to be the mass of the lift times acceleration, which we'll call equation 1. And then for the passengers, we're going to have 600 G newtons minus R, and that's going to be equal to 600 A. And then if we did 1 plus 2, we're going to get 6,600 G minus T is equal to 6,600 A. This number 3 is the main equation of motion we're going to use. Right, during the first stage of the motion, the tension in the cable is 60,720 newtons. Find the acceleration of the lift during this stage. So if we use equation 3, which was 6,600 grams minus T is equal to 6,600 A, and then put my value of, for the tension in the cable, 60,720 into that, and then make A the subject, so that will be 6,600 G minus 60,720 divided by 6,600, and we'll take G as 9.8, which will give me an acceleration of 0.6 meters per second squared. Okay, if we find the length of the time for which the lift is travelling at a constant speed and find the deceleration. So what we've got to find here is this. But before we can do that, we've got to find this speed here. What is that speed here? Okay, so we know that the area under this graph must be 324 because the area under a speed time graph gives us distance travelled. Okay, so find the speed after 12 seconds. Okay, to do that, I'm going to use Suvat. V is equal to U plus AT. So my speed will be V is equal to U, 0, starts from rest, plus 0.6 times 12, which gives me 7.2 meters per second, and I'll put that on my graph. And now I can use the area of the graph. So this is a trapezium, so it's going to be 60 plus t times the height of that trapezium, which is 7.2, divided by 2, and I put that equal to the area, which is 324, which was given in the question. And then I'm going to do 60 plus t. That will give me, if I multiply by 2, divide by 7.2, I get 90, and therefore t is a nice 30 seconds. So I'm going to mark that on my graph. That's 30 seconds. And therefore this time here will be 12 plus 30, which is 42 seconds. Right, so to find the deceleration, so I'm going to now find what this deceleration is here. So for the deceleration, the time will be 60 minus 42, which is 18 seconds, and the initial velocity, because it's going to slow down from 7.2 meters per second of the speed. Therefore, using v is equal to u plus at, I'm now going to put 0 is equal to 7.2 plus a times 18, 0, because it's going to come to rest. Make a the subject, that's going to be minus 7.2 over 18, which is minus 0.2 meters per second squared. Now, we expect it to be negative because the lift is going downwards, and therefore the acceleration is acting upwards against it, which is negative in this question. Okay, it says then, what's the maximum value of the tension in the cable? Let's just do that first. So D, from 3, equation number 3 again. Okay, so when we have a constant velocity, A is equal to 0. Therefore, this is equal to 0. Therefore, T will just be equal to 6,600 G, which is 64,680 newtons. And then at deceleration, okay, we'll just put our value of A into here. We're going to get that T is going to be 6,600 G minus 6,600 times minus 0.4, which will give me 67,320 newtons. This will be the maximum tension. E. Just before the lift stops, one passenger experiences an upward reaction of 714 newtons from the floor of the lift. What is the mass of the passenger? Okay, so if we go draw a diagram of that one passenger, its mass mg is acting downwards. It will have a reaction with the lift of 714 newtons, and the acceleration just as it gets to the ground will be minus 0.4 meters per second. So setting up an equation of motion for this, downwards is positive. We've got mg minus 714 is equal to the mass times minus 0.4. So that will give me mg plus, because when multiply that will be negative, take it to the side, it will become positive. This will become positive over here. There's a common factor of m. So we've got m times g plus 0.4 is 714. Therefore, m will be 714 divided by g plus 0.4. And if we work that out, then the mass of the passenger concerned is going to be 70 kilograms. Okay, so it's been quite a long video to show you how to use a speed time graph to solve a mechanics lift problem. I hope you've understood. I'd ask you to consider subscribing to my channel, and I thank you very much for watching.